Intro. Welcome back to our channel. Today, we're diving deep into a topic that's not just trending, but critical for anyone working in the field of artificial intelligence and machine learning: building a scalable AI model deployment pipeline. Whether you're a data scientist, a machine learning engineer, or a data engineer, understanding how to efficiently transition your models from development to production is essential. In this video, we'll break down this process into 5 clear, actionable steps that will help you create a robust deployment pipeline. So, without further ado, let's jump right in. Step 1. Define your goals and requirements. The first step in building a scalable AI model deployment pipeline is to clearly define your goals and requirements. Before you even begin developing your model, it's crucial to understand the business problem you're trying to solve. What are your key performance indicators? Are you aiming for accuracy, speed, or perhaps cost efficiency? What are the constraints and limitations of your project? By identifying these factors early on, you can better inform your model development process. You'll want to engage with stakeholders to gather their expectations and insights. This collaboration can lead to a clearer understanding of what success looks like for your project. In addition to defining your goals, you should also outline the technical requirements. This includes understanding the computational resources you'll need, the data you'll be working with, and any regulatory compliance that may apply to your model. By establishing these parameters upfront, you can make informed decisions down the line and set the stage for a successful deployment. Step 2. Develop and train your model. Once you have a clear understanding of your goals and requirements, it's time to dive into the actual development and training of your AI model. During this phase, you'll begin by choosing the right algorithms and tools that best fit your problem set. This can vary widely depending on whether you're dealing with supervised or unsupervised learning, natural language processing, computer vision, or any other specialized area of AI. Make sure to follow best practices in model development, such as splitting your dataset into training, validation, and test sets. This will help you avoid overfitting and ensure that your model generalizes well to unseen data. While training your model, consider using frameworks that facilitate experimentation, like TensorFlow or PyTorch. These frameworks not only provide the necessary libraries for building complex models but also have built-in tools for monitoring training progress. This is crucial for tracking metrics and making adjustments as needed. Once trained, evaluate your model's performance on the test set against the KPIs you defined in the first step. If your model is not meeting your expectations, don't hesitate to iterate. Adjust your hyperparameters, experiment with different algorithms, and revisit your feature engineering techniques. Step 3. Implement continuous integration and continuous deployment, CI/CD. Now that you have a trained model, the next step is to implement continuous integration and continuous deployment, often abbreviated as CI/CD. This step is vital for ensuring that any updates or changes to your model can be seamlessly integrated into your production environment. Start by setting up a version control system, such as Git, where you can keep track of changes to your codebase. This is also where CI/CD tools come into play. Platforms like Jenkins, GitHub Actions, and GitLab CI/CD allow you to automate testing and deployment processes. As you push changes to your code, automated tests can verify that everything is functioning as expected. In the context of AI model deployment, this means you can run tests to validate not just your code but also your model's performance. You can set up a testing suite that evaluates your model against predefined benchmarks to ensure it still meets the required standards. Once your tests pass, you can automate the deployment process. This can involve pushing your model to a cloud service, containerizing it with Docker, or deploying it on an orchestration platform like Kubernetes. Automation in this step significantly reduces human error and speeds up the deployment process. Step 4. Monitor and maintain your model. The deployment of your model is not the end of the journey, in fact, it's just the beginning. The fourth step in building a scalable AI model deployment pipeline involves monitoring and maintaining your model once it's live. Monitoring is crucial for assessing your model's performance in real time. As your model processes new data, you'll want to ensure that it continues to perform well over time. This might involve tracking metrics such as accuracy, latency, and resource utilization. Set up alerting mechanisms that notify your team if your model's performance dips below a certain threshold. This is where observability tools come into play. Platforms like Prometheus, Grafana, and ELK Stack allow you to visualize your model's performance and get insights into any anomalies. Another important aspect of this step is model retraining. Over time, the data that your model encounters may change, a phenomenon known as data drift. This can lead to a decline in performance. Therefore, you'll need to plan for periodic retraining of your model using updated data. Automating this process through your CI/CD pipeline can help ensure that your model remains relevant and effective. Regularly review your monitoring data to identify patterns and areas for improvement. Use these insights to optimize your model and the pipeline itself, ensuring you stay ahead of any potential issues. Step 5. Scale your deployment. Finally, the last step in building a scalable AI model deployment pipeline is planning for scalability. As your application grows and the demand for your AI services increases, you need to ensure that your deployment can handle the load. Start by evaluating your current infrastructure. Are you using a cloud-based solution that can easily scale resources up and down? If you're using on-premise servers, you may need to consider adding more hardware or transitioning to a cloud provider for greater flexibility. Utilizing containerization technology like Docker can also help with scaling. By packaging your model and its dependencies into containers, you can easily replicate and deploy multiple instances of your model as needed. Kubernetes can manage these containers, automatically scaling them based on incoming traffic and resource usage. In addition to infrastructure, you should also think about the architecture of your application. Microservices architecture is a popular approach for scaling as it allows different components of your application to be developed, tested, and deployed independently. This is particularly beneficial in an AI context, where different models may serve different purposes. Finally, consider using advanced techniques like load balancing and caching to optimize performance further. Load balancers can distribute incoming requests across multiple instances of your model, ensuring no single instance becomes a bottleneck. Caching frequently accessed data can also speed up response times and reduce the computational load on your models. Conclusion. And there you have it. Those are the 5 essential steps for building a scalable AI model deployment pipeline: defining your goals and requirements, developing and training your model, implementing CI/CD, monitoring and maintaining your model, and finally, planning for scalability. By following these steps, you can ensure that your AI models transition smoothly from development to production while remaining robust and effective in a live environment. Remember, the key to success in AI deployment is continuous iteration and improvement. If you found this video helpful, please give us a thumbs up and subscribe to our channel for more insights on AI and machine learning. Drop your questions and comments below. We'd love to hear your thoughts and experiences in deploying AI models. Until next time, keep innovating, and we'll see you in the next video.